Hi everyone, this is the explanation video of exercise 5 in chapter 8, which is about area. Exercise 5 is about 4 triangles where you need to calculate the area. It says, calculate the area of each of the triangles in squared centimeters. Now, this is the first triangle. I made a sketch. You don't necessarily have to do that because you can just look at the book. What you have to do is you have to write down what you're going to calculate. In this case, is area triangle. This is a triangle sign, ABC. You have to write it down. You can start the calculation right away. First, write down what you're going to calculate. So, first you write down what the formula is. It's base times height divided by 2. So, base times height and then divided by 2. Now, we're looking for a base and then a corresponding height. So you always look for the 90-degree sign and you do divided by 2. Why divided by 2? Because we forget that when you don't do divided by 2, you're actually calculating the whole rectangle, if it was a rectangle. But it isn't, it's a triangle, which is actually the half of it. So that's why you're doing base times height divided by 2. Let's get started. I just copy it, but I just write it down a little bit shorter. For area, I write down A. Base. Base is always the outside of a triangle. So the outsides of a triangle are AB or BC or CA. It's always the outside, so never look in the inside, okay? Now, I don't know what AB is, so I can't use it as a base. I don't know what BC is, so I can't use it either. I do know what this side is, so I am going to use this as a base, which is 12. And then you're going to check out if you can find a 90-degree sign here. Now, this is the base, and I can see a 90-degree sign here, which means this is the corresponding height. DB is the corresponding height. Base, 90-degree sign, this is the corresponding height. So that's, it says it's 9, so 9 divided by 2. A lot of students, they forget divided by 2. Because when you're kind of messy with your calculations here, it's very easy to forget. So please don't forget, okay? Now, again, area, triangle ABC is... You just simply do this in your calculator. When I type it in my calculator, it's 12 times 9 divided by 2 is 54. Now, in the question it says in squared centimeters. This is also centimeters, so squared centimeters. Next. Triangle KLM. Of course, you first write down the formula, base times height divided by 2. Let me just write it down one more time. Then I can do my calculation right here. I'm going to start looking at the base. The base is always the outside of a triangle. I don't know what this is. I do know what this is, and I also know what this is. So either I'm going to use this as a base or this as a base. It's depending on what else do I know from this triangle. So I need, of course, the corresponding height. Okay, first let's have a look at this base. If I go along this side and I'm looking for a 90-degree sign, is there a 90-degree sign here? No, there's not. So you know what? I can't use this side. Why did they give this to you? Just to confuse you a little bit. All right, so don't use this. Now, I'm going to look at this base. 8 plus 4 is 12, so this side, outside, this triangle is 12. Is there a 90-degree sign here? Yes, there it is. So that means that KN is the corresponding height. Base is 8 plus 4, so 8 plus 4, which is of course 12. I'm doing it in brackets, so it's very, very clear that this is 12, and also because otherwise, according to the order of operations, you first have to do multiplication and then plus. So therefore I do it in brackets. Height, let me see, that's Kn. I don't know what Kn is. So, whenever you come to the point that you don't know what a side is, you're going to check out if you can use Pythagoras' theorem. Can I see a triangle here with a 90-degree sign? Yes. I can use this small triangle, KNM, or I can use this small triangle, KLN. And I do know what this side is. I want to know what this is, because that's the corresponding height. Once I know it, I'm done with the calculation. But I don't know what it is yet. I can't use this small triangle because, I don't know what this is. Let me check out this small triangle. I do know what this side is, and I do know what this side is. So I believe I can do Pythagoras' theorem here. I'm just going to leave this open and we'll come back to this later. I will come back to it later. Side, square. Remember Pythagoras' theorem, chapter 4? I'm going to use this small triangle, okay? First, the two sides that are connected to the 90-degree sign. That's KN and LN. Then the side is opposite of the 90-degree sign, which is the hypotenuse. KL. KN. I don't know what it is. I'm going to leave it open. LN is 8 and KL is 17. 8 squared is 64. 17 squared is, check it out, 17 squared is 289. Plus 64 has to be 289. So 289 minus 64. It's 225. So I'm going to write down here what I need to do. Kn squared is 225. So Kn is the square root of 225. Oh, I know that one. That is, you know your list, right? What is it? 15. Now it's a whole number, so I can use that whole number in my calculation here. What if it was not a whole number? And then you use the square roots, okay? Because you can round off, because we're not at the end of our calculation yet. So in the middle of a calculation, you can never round off. Now I'm going to use 15 divided by 2. Don't forget that one. This is of course 12, so I will just immediately triangle KLM. I will immediately write down 12 times 15 divided by 2. 90. This was in millimeters. Squared millimeters, but in the exercise it says that you have to round off to squared centimeters. So let me change that. When it's squared, it goes with steps of 2. So this has to be 0.9. Oh, it doesn't fit. Squared centimeters. Okay, this was triangle 2. Done. All right, this is triangle PQR. Let me write down the formula right away. Base times height divided by 2. So the area of triangle PQR is base. Let's start with the base. I'm going to look at the outside of the triangle, and this is the triangle, this, PQR, not this. It's very important. This is just air. Okay, so this is a triangle. This is an outside. I know this outside. I know this outside, and I don't know this outside. So I can't use PR. Let me check out if I'm going to use PQ as a base or QR as a base. If I'm going to use PQ as a base, I have to look for a 90-degree sign. I'm going to check it out. Do I see a 90-degree sign? No. But in this case, I can extend this line, and that's why it's dotted. I can extend this line, and yes, there is a 90-degree sign, which means this is the corresponding height. It's 7. So with this outside, this is the corresponding height. It doesn't matter, it is all the way over here. It's still, I'm gonna write in my triangle right now. This from here to here is still 7 centimeters. It doesn't matter where it is 7 centimeters, here, or here, or here, or here, it doesn't matter. It's still the corresponding height. And that's what it's about. Now, what I see what a lot of students do is that they calculate what this is with Pythagoras theorem. Don't do that, because you don't need this. You don't need how long this is. We don't want to know that, because this is just air. It's nothing. It has nothing to do with the triangle. This is a triangle. Okay, so the base is 10, and the corresponding height is 7 divided by 2. So the area of triangle PQR is 70 divided by 2, so that is 35. Don't need my calculator here. Hey, it's given in centimeters, so it's squared centimeters and done. Alright, so this is the last triangle, a triangle VWX. Of course, B times height divided by 2. So the area of triangle VWX is, now, base, always look at the outside of a triangle. This, again, this is the real triangle. This is just air, okay? So this is the outside of a triangle. This is the outside of the triangle. This is the outside of the triangle. I know this outside and this outside. So, or this can be the base, or this can be the base. It's just depending on what else do I know for the corresponding height. Now, first let me check out this side. Let's check if I can use it as a base. Do I see a 90-degree sign? If I have my finger here, I'm going to look all the way along this side. Do I see a 90-degree sign? No. That means there's no corresponding height. Now, check out this one from V to W. Is there a corresponding height? No. But what if I extend this line? I extend it with dot, 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 dot. Yes, there's a 90-degree sign, which means this is the corresponding height, x, y. Now, let me write it down. The base is 14, not 14 plus 9. No, this is just air. There's nothing to do with this triangle. So it's only 14 times the corresponding height is x, y. I don't know what it is. Just let me write down x, y. Then I will fill this in later, okay? I just find that handy because sometimes you forget what you're calculating or whatever, and now you know that you want to calculate x, y. So area, let me just write it down one more time. And now I'm gonna leave it open. Question mark here. Let me focus on this now. How am I going to calculate this length? If you need to calculate another length, you try to do that with Pythagoras theorem. Now I can see that there's a triangle here, a small triangle with a 90-degree sign. I know this side, I know this side, which means I can do Pythagoras theorem. Let me do it here. Some people, they do this real quick on their calculator, but you know what happens then? You miss your calculations and then you miss points. So don't do that. Do this in a table and write down all your calculations, okay? Hey, the 90-degree sign. Which two sides are connected to the 90-degree sign? That's Vy, which is 9, and Xy, which is, I don't know. The opposite, the hypotenuse, is Vx, which is 15. Now, 9 squared is 81. I don't know this one. And 15 squared is 225. 81 plus is 225. Let's check it out. So that's 225 minus 81 is 144. Okay, so you have to write down xy squared is 144. Xy is the square root of 144. Hey, that's also a whole number. It's 12. Let me fill it in. 12 divided by 2. Now, again, area of triangle 14 times 12. What is that? 14 times 12 divided by 2. And that's 84. Okay. 84. Let me check. The unit is millimeters. So it has to be squared millimeters. But it says in the exercise, round off to squared centimeters. Not done yet. Is sign. It goes with 2 steps. because it's squared, so this is 0.84 squared centimeters. Done. This was the end of the video. I hope this was helpful to you, and well, see you in the next video. Thanks for watching.